Hey friends, how are you all? So in this video we are going to discuss 10 most important naming reactions with some tricks. So let's start the video. The reason that out of 10 I've taken these 3 reactions together is because in some aspects they are similar to each other and it will be convenient for you to learn this reaction. For example, in 3 of these reactions, in Wood's Fittig as well as Wood's Fittig reaction, the reactant is same, sodium metal. In 3 of this we are taking dry ether and the product form will be 2NaX in 3 of this. So it will be convenient for you to learn these reactions easily. Now in the first reaction, Wood's reaction, we are taking alkyl halide. Here the R is the functional group and it is alkyl one. It is in chain form. We are reacting it with sodium metal in the presence of dry ether and the product form will be alkene and NaX. Similarly, in the Fittig reaction, we are taking aryl halide in presence of alkyl halide and remaining all things will be same, just the product will differ according to the reactants. And third one, the Wood's Fittig reaction, here it is the combination of both Fittig as well as Wood's reaction. So how? So it's like we are taking both aryl as well as alkyl halide, reacting it with sodium metal in the presence of dry ether, and the product form will be alkyl arene with release of 2NaX. Just like those 3 reactions, now we will see Finkelstein and Schwarz reaction. In Finkelstein reaction, we are reacting alkyl halide with sodium iodide. In Schwarz reaction, we are reacting alkyl halide with the fluoride compounds. Here are these 3 fluoride compounds which you need to remember. In Finkelstein reaction, iodide compound. In Schwarz reaction, fluoride compounds. Now I will give you a trick by which you can remember this. Here, Finkelstein starts with F and we are using iodide compounds as reactant. Schwarz starts with S and we are using fluoride compounds F. So just remember that 2F cannot meet each other. 2F cannot meet each other. By this way, you can easily remember it. Another way, Finkelstein reaction, Rx is the alkyl halide and NaI is the sodium iodide. X is halogen, I is also halogen. So there will be interchange among these halogen compounds and the product form will be Ri and NaX. Similarly, in Schwarz reaction, RBr and HEF. So Br is the halogen one, F is also halogen one. So there will be interchange among this and the products form will be RF and HEBr. Another way to remember Finkelstein reaction is by a picture. Yes friends, by only one picture you can remember Finkelstein reaction. This is a barber and we all know that in India we call a barber as a nai. In chemistry language this is sodium iodide and in Hindi this is nai. So now whenever you will see a barber, your mind will just struck this word Finkelstein and you can easily remember it by this trick. Now we will see Sedmeyer reaction and Betterman reaction. By comparing these 2 reactions, we can easily remember them. In Sedmeyer reaction, aniline is treated with HNO2 or HCl or NaNO2 or HCl in the temperature range of 0 to 5 degrees Celsius and we will get benzene diazonium chloride. This reaction is known as diazotization reaction. See friends, this is very important reaction, so you need to hear this carefully. Then further reaction is Sedmeyer reaction. Here we are reacting benzene diazonium chloride in the presence of Cu2Cl2 or Cu2Br2 catalyst and we will get chlorobenzene and bromobenzene in the product side. And Betterman reaction is similar to Sedmeyer reaction. There is aniline and we in the presence of NaNO2 or HCl and the same temperature range 0 to 5 degrees Celsius, we are getting diazonium salt. By reacting it with Cu powder in the presence of HCl or Cu powder in the presence of HBr, we are getting chlorobenzene or bromobenzene. So these reactions are almost similar to each other. Just you need to remember some of those terms like this temperature range or this reactants and like that. In Getterman reaction, we use Cu powder. Inside Meyer reaction, we use CuCl2 or CuBr2 as catalyst. So you can remember it easily. In Bals-Kaiman reaction, diazonium salt, which we get from the Getterman reaction, is treated with HbF4, which is fluoroboric acid. HCl will be removed and we will get this intermediate product, and by heating it we will get fluorobenzene and the following products. Now the last two reactions are Kolbe-Smith reaction and Reimer-Teimen reaction. These two reactions are very important. There are a lot of similarities in both these reactions. For example, in this reactant side, we used phenol in both of them. The product side in Kolbe-Smith reaction is salicylic acid is formed, and in Reimer-Teimen reaction, salicylaldehyde is formed. The structural formula is also a lot similar. Here COOH group is placed and here aldehyde group, and there are much more similarity. There are two steps in these reactions. In the first step, NaOH CO2 is used at 400 Kelvin and 4 to 7 atm. In Reimer-Teimen reaction, the first step, we use CHCl3 NaOH at 340 Kelvin. So in both these steps, the NaOH is similar. Just in Kolbe-Smith reaction, we use CO2, and in Reimer-Teimen reaction, we use CHCl3. And second step, dilute HCl is used in both these reactions. So you can easily remember it by this. Now we will see the mechanism of Kolbe-Smith reaction. Phenol is treated with NaOH. So by releasing a water molecule, sodium phenoxide will be formed. How? So one H atom of phenol will react with OH of NaOH, and the remaining Na will be placed in place of H, and sodium phenoxide is formed. Now sodium phenoxide is reacted with CO2 at 400 Kelvin and 4 to 7 atm pressure, and this intermediate product is formed. On rearrangement, Na and H will change their place and this product will be formed. On the acidification with dilute HCl, NaCl will be removed and we will get salicylic acid, which is 2-hydroxybenzoic acid. So this whole reaction is termed as Kolbe-Smith reaction. Now in Reimer-Teimen reaction, the mechanism is phenol is reacted with CHCl3 and 2NaOH at 340 Kelvin. NaCl and H2O will be removed, so we will get this intermediate product. On further reaction with 2NaOH and removal of 2NaCl, we will get this product. On heating this product, the H2O molecule will be removed, and by acidifying it and removing NaCl molecule, we will get salicylaldehyde. So these two reactions are almost similar to each other. By practicing it, you can easily remember these reactions.